We expect AI to handle our digital errands, but often find it failing or hallucinating when asked to book a simple flight. The problem is architectural. The internet was designed for human eyes, relying on a visual language of buttons, forms, and layouts that machines have to interpret. This shows an AI agent trying to navigate a standard page. It has to take a screenshot and use vision models to blindly guess where to click, often confusing a checkout button with a newsletter sign-up. Forcing an advanced machine to interpret a visual interface is wasteful and creates constant points of failure. At Google I/O 2026, the company announced a shift to the agentic era of computing. Central to this is Gemini Spark, an always-on background agent designed to execute multi-step tasks like ordering groceries or managing a calendar autonomously. To power the commerce side, they introduced Universal Cart, a centralized engine that lets these agents handle research, execute the checkout, and track orders across merchants. But Google realized that making the AI smarter wasn't enough to fix the friction of navigating the visual web. To make autonomous agents viable, they had to build a new foundational language for the internet itself. The hardware upgrades were the first step. Google introduced TPU-8T and 8i chips, custom silicon built to process quadrillions of tokens per month with minimal latency. They paired this with Gemini 3.5 Flash, an AI model optimized for output speed and taking action rather than slow, deep reasoning. Then came Anti-Gravity 2.0, the orchestration layer that manages cohorts of these agents as they work in the background. But this full-stack ecosystem is ineffective if deployed into an unpredictable, unstructured web environment. Raw computing power cannot fix a disorganized internet. The web must meet the AI halfway. For years, we used schema.org to organize data. It gave the internet nouns, labeling code as a product or an event. While schema labels a shoe, the Web Model Context Protocol gives the internet verbs. It defines exactly what an agent can do. Running in the browser, it hands the AI a structured menu of tools, bypassing the visual layout. Instead of trying to find and click pixels on a screen, it triggers a book flight tool directly via code with 98% accuracy. This transforms websites from passive pages waiting to be read into active tools waiting to be executed. This creates a two-tiered architecture for the web, a visual layer for humans and an invisible executable layer for machines. Agents like Gemini Spark live in this second layer, completing complex, long-horizon tasks like comparing market prices or booking travel while the device is closed. This executable architecture powers Google's new hardware, including the audio-first intelligent eyewear developed with Samsung. Because the agent handles the spatial logic of the web through the protocol layer, the user only needs to provide verbal intent. The screen is no longer the necessary middleman for navigating complex digital transactions. For decades, the web economy was built on traditional SEO, optimizing keywords to capture human attention and clicks. We are entering the era of web MCP SEO. Here, a website's survival depends on exposing precise, actionable tools to AI agents. Websites that fail to provide a clear tool contract for machines will be bypassed for those that are easier for agents to command. The future of the internet belongs to sites that prioritize machine readability and direct execution over human-centric visual design.